Now let us discuss about the relation between beta and gamma function. So it is defined as beta of m comma n must be is equal to gamma of m into gamma of n divided by gamma of m plus n. So this is about the property or relation between beta and gamma function. Now let us see uh, the definition of all these things. So I'm going to prove this now. This is also very important relation. So now first I'm going to define beta of m comma n is equal to, as per the alternative form, I can define it as 2 into integral 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta d theta. As per the definition, we have beta of m comma n is equal to 2 into integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta. In the same way, gamma of n is equal to 2 into integral 0 to infinity e power minus x square into x power 2n minus 1 dx. So this is the alternative form of gamma function. I can written in terms of x. So in the definition we have replaced it as theta. So you can write it is in any variable. In the same way, gamma of m can also be written as another variable 2 into integral 0 to infinity e power minus y square y power 2m minus 1 dy. In the same way, gamma of m plus 1 I want to define, that is m plus n is equal to 2 into integral 0 to infinity e power minus, in terms of r I am going to write this e power minus r square r power 2 into, in the place of m we have m plus n, so m plus n minus 1 dr. So these are the three definitions for three different variables. So gamma of n into gamma of n and gamma of m plus n. So now what I am going to do is I am going to multiply gamma of m into gamma of n or gamma of n into gamma of m. So that means if I multiply these two integrals, we'll get 2 into integral 0 to infinity e power minus y square into y power 2m minus 1 dy into 2 into integral 0 to infinity e power minus x square x power 2n minus 1 dx. So if I multiply these two integrals, I can rewrite it into double integral. That means 2 into 2, we get it as 4 integral 0 to infinity e power y square into e power minus x square can also be written as, since bases are same, powers will be added. So e power minus of x square plus y square, x square into y square. I can write x power as 2n minus 1 and y power as 2m minus 1 dx dy. Dx into dy I can write. So if I multiply these two integrals, I will get this as the integral value. Now evaluate or multiplying these two definition, we got this term Now we are going to evaluate above integral in polar form. So I am going to evaluate this integral into polar form. That means I have to take the substitution in the place of x as cos theta and y as sin theta. If x is equal to cos theta and y is equal to I have to replace x as r cos theta and y as r sin theta. X value I am going to replace it as r cos theta and y value I am going to replace it as r sin theta. It implies x square plus y square is equal to r square into cos square theta plus sin square theta is 1. So I can replace it as x square plus y square is equal to r square. Also dx dy can be replaced it as r into dr into d theta, r into dr into d theta, where r ranging from 0 to infinity. In the same way, theta ranging from 0 to pi by 2. R ranging from 0 to infinity, theta ranging from 0 to pi by 2. How we got these limits is nothing but if I identify the boundary region here as x ranging from 0 to infinity, in the same way y ranging from 0 to infinity. X value ranging from 0 to infinity means x value is 0 on y axis, so that means this part, and y value ranging from 0 to infinity means y is 0 at x axis, that means this part. Since we got the checks in the first quadrant, so theta ranging from 0 to pi by 2, r is nothing but the radius since it is completely first quadrant, so x value or r value, radius ranging from 0 to infinity since it is complete first quadrant. So in this way we can define the regions. So now rewrite that given equation. So this equation I am going to replace it as equation 1. So equation 1 can be written as gamma of m plus n. Gamma of m plus n is equal to 4 into integral 0 to infinity integral 0 to pi by 2 e power x square plus y square is there, that can be replace it as e power minus r square. X value can be written as r cos theta whole power we have 2n minus 1, and y value can be replace it as r sin theta whole power 2m minus 1. Dx dy can be written as r dr d theta. So I have replaced x square plus y square as r square, x value as r cos theta and y value as r sin theta. Now this one is equal to 4 into integral 0 to infinity integral 0 to pi by 2 e power minus r square into r power 2n minus 1 is there into r power 2n minus 1 is there into cos power 2n minus 1 theta into sin power 2m minus 1 theta. So I have splitted the powers. Now since bases are same here for r, so power should be added. So this one is equal to 4 into integral 0 to infinity integral 0 to pi by 2 e power minus r square r power 2 into, or you can replace the powers as 2n minus 1 plus 2m minus 1 into cos power 2n minus 1 theta into sin power sin power 2m minus 1 theta into r. That means I can write it as plus 1 here. So dr d theta we have. So total 3 r terms are there. One is r power 2n minus 1, r power 2m minus 1. Here in the place of dx we have dx dy, we have r dr d theta. So r dr d theta. So here also r power 1 is there. So overall 3 terms. So 3 powers have added 2n minus 1 plus 2m minus 1 plus 1. So this one is equal to 4 into integral 0 to infinity integral 0 to pi by 2 e power minus r square. This can be written as here plus 1 and minus 1 get cancelled. R power 2 into m plus n minus 1 into cos power 2m 2n minus 1 theta into sin power 2n minus 1 theta 2m minus 1 theta. Let us rewrite this as cos power 2n minus 1 into sin power 2m minus 1 theta dr d theta. Now this above double integral I am going to split into single integral as integration for r separate and integration for theta separate. All r terms should be come under dr integral. So integral ranging from 0 to infinity, because here integral for 0 to infinity related to dr term. So I can replace it as integral 0 to infinity e power minus r square r power 2m plus 1 2m plus n minus 1 into dr. This is about all r terms into 2 into integral 0 to pi by 2. That means second integral related to theta. So I can write as cos power 2n minus 1 theta into sin power 2m minus 1 theta d theta. So now if you observe the definition of this first integral, this is nothing but the definition of gamma of m plus n. So gamma of m plus n I can write. Instead of first integral I can write it as gamma of m plus n into second integral is the definition of beta function. So beta of m comma n. So finally we got gamma of m into gamma of n is equal to, we got it as gamma of m plus n into beta of m comma n. Now I can rewrite this as beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. So this is how we can prove beta relation between beta and gamma function. Using this property, I am going to prove gamma of 1 by 2. Using this relation, I am going to prove gamma of m1 by 2 is equal to root pi. So let us see how will I prove this. So since we know beta of m comma n, according to the property as gamma of m into gamma of n divided by gamma of m plus n. So that means take m is equal to half comma n is equal to half, I'll get beta of half comma half is equal to gamma of half into gamma of half divided by gamma of 1. Gamma of half into gamma of half divided by gamma of 1. Since as per the standard value of gamma of 1 must be equal to 1, because n into gamma of that's it. This is the standard value of gamma function. So I can write gamma of 1 by 2 whole square must be is equal to beta of 1 by 2 comma 1 by 2. Now I have to find the value of beta of 1 by 2 comma 1 by 2. So let us see the value of beta of 1 by 2 comma 1 by 2. As per the alternative form of beta of m comma n, we have 2 into integral 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta d theta. That means I am going to replace m and n as half comma half in this integral. So 2 into integral 0 to pi by 2, in the place of m if I replace half, so sine power 2 into 1 by 2 minus 1 theta into cos power 2 into 1 by 2 minus 1 d theta. So that means 2 into integral 0 to pi by 2 sine power 0 theta we have into cos power 0 theta d theta. So anything power 0 we will get it as 1. So I can replace it as 2 into integral 0 to pi by 2, we have 1 into d theta. So integration of this value is nothing but 2 into integration of d theta is theta ranging from 0 to pi by 2. So that means 2 into, if I apply upper limit minus lower limit, pi by 2 minus 0. So that means 2 into pi by 2. So that means pi value will get. So 2 to get cancel, we'll get it as pi. So this is the value of beta of 1 by 2 comma 1 by 2. We got it as pi. But as per equation 2, write this as equation 2. From equation 2, we have beta of 1 by 2 comma 1 by 2. We have gamma of 1 by 2 whole square. So that means gamma of 1 by 2 whole square is equal to the value of beta of 1 by 2 comma 1 by 2 is pi. Finally we got gamma of 1 by 2 is equal to root pi. So square, if I send right hand side, we'll get root pi. So finally we got gamma of 1 by 2 is equal to root pi.